Real analysis. Sequences of real numbers, convergent sequences. Last week, the last two weeks, we studied the sequences of real numbers and the convergence and divergence of those sequences. I gave you some homeworks and I asked you to solve it. I think we are done with this one. We discussed all the topics related to these exercises, and I think now we can go further. Okay, now also binomial theorem. For binomial theorem, we studied the binomial theorem. Binomial theorem, it is actually from your previous studies in mathematics. It is some elementary sequence, and this is called the binomial coefficient. You see, binomial coefficient is n of k, n and k. It is n factorial, k factorial. Also, we solved a few problems on this topic. Today, we will continue our discussion, and I'll discuss very important corollary, which says if a sub n is a convergent sequence of real numbers with limit when n approaches infinity, a sub n equals a. A is some constant, therefore any c is another constant belong to R, then limit of n approaches infinity of a sub n plus c equals a plus c. A is the value of this limit. Now, I'll explain this one through an example. Compute limit approaches infinity of 2n plus 1 over 3n plus 2. Now, solution. For solution will be like this. The first thing, 2n, I'll write 2n plus 1 over 3n plus 2. I can write this one as divide the numerator and denominator by n. So this will be, I think I explained the concept behind this procedure. It will be like this. I explained this one in the beginning of this course. So I write this one in this, you see. It can be written like this. Okay? It is just this. I obtain this one from dividing this one by n and this one by n. So here you see, if I 2n plus 1, if I divide by n, then n will be here, 2n over n plus 1 over n. Okay, the same thing for denominator. It will be 3n over n plus 2 over n. This one gone, so it will be 2 plus 1 over n over 3 plus 2 over n. So this is how we obtained this one. Okay, now I'll take the limit for this and I'll take the limit for this one. This for numerator and denominator. Now the limit for n approaches infinity, 2 plus 1 over n, it will be using this corollary, because you see this is the value and this is the constant and this is the value. So the limit for this one is equal to 0. So only I'll be left with the constant. So it will be 2 plus 0 or 2. The same thing for denominator. Limit of n approaches to infinity, 3 plus 2 over n, the same corollary. You see this one? It is 3 plus 0. Why? Because 2 over n and 1 over n, if the denominator approaches infinity, then 2 over infinity equal to 0. So this one also 3 over infinity equal to 0. So here you see 0 and 0. Now, and this equals to 3. So if I plug in this one, so that means the limit, the required limit, and approaches infinity of 2n plus 1 over 3n plus 2 equals to 2 over 3. And this would be the answer for this question or for this example. Okay? Now, another example. I'll take example 2.